Hello and welcome to everyone. My name is Supriya Gupta Bani, Assistant Professor of Computer Science and Engineering with Data Science from Ramdev Baba College of Engineering and Management. Object detection and recognition are my theme for today. So let's begin with a brief synopsis of object detection and recognition with its outline. So there are basically two major points, that is object identification and the second one is object recognition. As we can see in the figure, the various models, various objects are showing in the figure, but the object we have to find out, that object is face. So the object is face and we have to identify the object face. Then the second one is recognition. Now the specific person's face we have to recognize. Now we can see here, where is Jane? Jane is a particular person, and where is face? Face is a particular object that you have to find here. So if there is a face in the image, first we have to find this. That process is called object detection. So if the image can show this object, like various phases are there, so yes, the objects is there. Now the another level of object recognition is, so if where is Jane, the particular function of Jane's features or face is called object recognition. After object detection, we can recognize the face of Jane with the multiple object detection functions. Where object detection task is a given input image, determine if there is object of given class. Class is basically object class where faces, people, car, etc. we can consider as object in the image, and where they are located, means the object can find in the image, that is object detection, and recognition of a specific task, that is called object detection. In this image we can see the various phases as like object class, and the object detection is going to find the object. Now we can see the yellow squares, that is showing the faces of each person. Now what is it? It is a object detection function, not recognition. We are not recognizing any specific person here. We are going to recognize only face. The face features is containing eyes, nose, lips, cheeks, hairs. So these are basically a class of a face, and the square objects can show you the object like face. So all the faces of each person is detected as object detection. We can see the classifier must generalize over all exemplars of one class. Negative class consists of everything else that is not included in our required feature. Basically these are the detection problem where we can see the positive class or negative class. What is positive class? If we can say the faces are positive class, means we have to recognize or detect the faces. And what is the anything else or negative class? So we can consider that dresses, the car, the another spaces, another objects that we do not want in our class, that is the negative class. High accuracy, small FP rate required for most application in the detection problem. Likewise, in previous image we can see all faces are detected, but they all are positive class. What is the negative class? In that image we can see the tree in background, we can see the car in background, we can see the home in background. That is the negative classes because we do not needed or we cannot consist this as my object. So this is the object detection. Basically we are going to detect face in the basic scheme where we can see there are multiple type of training data set. Now what is training data set? Where we are train our model with the given data. That data should be anything, like if we are considering our training data set, we can see here the phase example, the non-phase examples are considered as training. Suppose one image you can find and then you have to detect the phases from there. So what can be done? We have to train our model with phase and with non-phase example. With phase you can understand the eyes, nose, lips, cheeks are there, forehead are there. And what is the non-phase examples? Like tree, like car, like home, whichever not containing eyes, nose, lips, cheeks, that are non-phase examples. So we are going to train our model with this type of examples so that our model can detect each and every specific class from that. Now, we are processing this offline training with the pixel pattern. Search of phases at different resolution and location. What is different resolution and location? Now, if you are in home, if you are in classroom, if you are in another place, but your phase is same, so the location is not matter, the phase is detected as it is where you are. Now, the resolution. What is the resolution? Suppose if you have the high pixel camera, your photo or your picture is clearly visible. If you have low or rainy season or cloudy season, your photo is blurred. But if the resolution is changes, it means not that you are not detected as similar object. So the basic resolution and location is the matters for object detection. Now, after the pixel pattern evaluation, we have to find feature extraction. What is feature extraction? Feature extraction is the basic part of object detection if we are going to detect the face. So what is the feature of faces? Feature of faces are again eyes, nose, cheeks, lips, chin, forehead, hair. These all are our features. So if we are going to do any class model or object model to find out the basic object or detect an object, we have to find first features for that extraction. If we are going to do the feature extraction of any part of car, so what are the features of car? The bonnet, the mirrors, the seat, the headlights, these all type of things are features that are detected with the car, that is detected that this object is a car. Okay. Now we have to do or we have to analyze the classifier. After creating the feature vector x1 to xn, it means ki feature extraction we can done with various or multiple problems like x1 to xn. The feature could be n and we have to recognize the features by this classifier. Now the training data is provided to the classifier and the new test data is also given to the classifier. In the basis of learning of the training data, the classifier is going to detect your object in the classification results. It means if your model is trained with a face recognition and the upcoming test data is concluding or containing the text as well as the another objects, then you can find the phases with this test data. Now we can find the classification results with the phase detection of basic schemes. In the training data sets, we can find two type of data set, that is labeled and unlabeled. What is labeled data set? Whenever we provide the labeled data set, it means we can write that we are giving to face. If the label is with face, this data is going to call the training data set with label data. Now, when we are finding the label data set as a test data set, we can classify it with the sensitivity problem. We have to define this image as face detection. So, in this image, we can see the square brackets are showing all the faces in classifying image. So, these are training and testing performed on object detection method. So OpenCV is the huge and approachable process, is open source library for computer vision, machine learning and image processing, and now it plays a major role in real time operation, which is a very important in today's system. By using it, one can process image and video to identify the objects, face or even the handwriting of a human. The article focuses on detecting objects. So we are going to learn the OpenCV and OpenCV code for object detection process. Now, object detection is a computer technology related to computer vision, image processing and deep learning that deals with detecting instance of the object in image and videos. Positive image. This image contains the image which we want our classifier to identify. Negative image. Images of everything else which do not contain the object we want to detect. It means if you find the training or test data set with faces, that is positive image. If you find some images that is not containing faces, is called negative images, because these are negative image that is not containing the face objects that we want. So these are the negative images. So we can see here, this is the image with stop red line, and we are going to detect the object stop here. This is your OpenCV code where we can import the CV2 from matplotlib, that is Python library, import pyplot as PLT. There we are firstly we are going to load the image with opening image. Image name is image.jpg. We can load the image with CV2 image load, and we starts the OpenCV to finding this image or show the image. Image color, image background, we can say the image can be detected in gray level or RGB. RGB means red, green, blue, means it colored image we can say, and the gray level image that is converted to gray, that is black and white image, that can be called that gray images are black and white image and RGB is the green, blue is colored image. Now the subplots are here 1.1.1, that is images in RGB. We can see that the given image is colored image. Okay, we can find here the given image of stop is processing with this Python code, where OpenCV code we have written here, and the JPEG image is loaded here as image, and the stop where we can see the red background with white front and a stop we can detect here. See, the green box is showing you that stop is the object. How can we detect this object? We are going to train our model with this stop. Stop image is considered as a training data. We are providing this training data to our model, and whenever this test data is arrived, the training model is compare these models or compare the images of stop. Whenever he find that yes, stop is there, the image will be processed out. Here the stop is as object of your object detection. So this is the output image where we can clearly see that green box is show you the output of stop. So performing object recognition using ImageAI. In this section, we will discuss how we can utilize the ImageAI library in Python. The procedure of performing object recognition is divided into several steps of the better understanding and clarity. In the step 1, the initial step is to create the necessary folders. For the tutorial, we will need the folder in given formats. So whenever we are going to use the Python, we have to store these libraries, these folders as the input form. Yeah, that is object recognition. This will be the root folder where model, the folder will store the pre-trained model. Input, the folder will store the image file or which we'll have to perform object detection, and fourth folder is output folder, will store the image file with the detected object. For the second step, we will open the preferred text editor, which is Visual Studio Code. In this case, to write a Python script and create a new file, that is recognizer.py. You can take any name of your file and you can code this in your file. We have given the name of recognizer.py. Py is a library of Python, so we have to show this file name as recognizer.py. Further, we are going to step 3. Let us begin importing object detection class from the ImageAI library. The syntax for the same is shown as below, like file name is recognizer.py, importing the required library from ImageAI.detection, import object detection. Now we are importing the object detection here with this line, ImageAI.detection, import object detection library. Moving with the further step, that is step number 4. The required ImageAI library is imported and the object detection class. The next thing is to create an instance of the class object detection. We have to find the instance of the class this object detection. Let us consider the following snippet of code for the same, like file name is again recognizer.py and initializing the class, that is recognizer is object detection. Now we have made our recognized object detection, that is the class. Step number 5, let us specify the path from the model input image, the output image using the following snippet of code. Again file name is recognizer.py, defining the path. How can we define the path? Here is the code for path model. It means we have to create or we have to input the images in our Python code. So we have to give the path or the folder path to the Python code so that they will carry our input images in their code. So the path model is models YOLO, tiny, h5, input image.jpg, where we have stored your input images. Exactly you have to give the path to take the input from that images. Next is the step 6. Once we initialized the object detection class, we can now all different function from the classes. The class consists of the following functions in order to call pre-trained model. Now what is this pre-trained model? Again we are going to use the training models to get the exact output from your test data. So these pre-trained model are already trained with the given examples or given phase or non-phase or positive class or negative class examples with this model. Now we can see the type of RetinaNet, YOLO 3, Tiny YOLO, these all are your pre-trained model where already the given images are stored. Yeah. For this lecture purpose, we will utilize the pre-trained Tiny YOLO V3 model and thus we will be using set model type as Tiny YOLO V3. That function is considered as load the model. Let us consider the following snippet of the code for the same. Again the file name and the set model, that is type as Tiny YOLO, that we have to import or load from the model where we are considering the pre-trained model. The next step 7, now we will be going to call the function set model path. The function will accept a string that consists of the path of pre-trained model. Let us consider the following snippet of the code for the same, where we are going to use the path for the input images. Similarly, we have to give the path of this pre-trained model to our Python code. Setting the path to pre-trained model is recognizer.setModelPath and path model. We are considering this path whenever we are storing this pre-trained model, and we are going to take this pre-trained model in our Python code. Yeah. In the next step, the call of load model function from the recognizer instance. This function will load the model from the path specified above with the help of this set model path class model. Let us consider the following snippet of the code. Like again, the file name is recognizer.py and loading the images with recognizer.load model. Again, we are going to load the model from the Python code. Now step 9, we have to call the detect object from image function. This function helps the recognizer object that will created earlier. This functions accept this model that have the detect object from image, means we have to consider the pre-trained model and the test data will come, and if you are having the pre-trained model with the given images, we can find the object detections from the test data. Yeah. So there are two parameters basically, input parameters and output parameters of image path. The input image parameters is the path where the image we recognize is suitable, whereas the output image path parameter is the path storing the image with detected objects. The function will return a diction of containing the names and percentage probability of every object detected in the image. The syntax for the same is showing in below, where we can see the file name is again recognizer.py, calling the detect object from image function. Recognition is recognizer.detect object from image, where we are taking the input image with the path input and output image is with path output. The step 10, at last we can access the dictionary element by iterating through each element present in the dictionary. The syntax for the same is showing below. The file is again recognizer.py, iterating through the items found in the image. For enhancement of the recognition, like print the name and the probability, the size of that images are going to add here in the code of Python. Now we are finding the each item and each model from the training data, and whenever we got the test data and finding this code of Python, we have to find out the exact output from the test data according to with the pre-trained model with the given objects. So in this way, there are many multiple types of objects are recognized by the object detection code, and we can find the car, bus, person, tree. These all are going to show you the different objects and their intensities in the given images. Now we can see that in this image we can see all the things and different type of objects we can see, like there is a car, cycle, human being, pole, and images are there. So whenever we are going to detect the object detection code, see the square areas are detected for car also, the squared area are detected for bus also, and then we find the different type of intensity of the different object with the different object detection code, because we have the pre-trained model with all storing these images of car, bus, persons. So when we applied the object detection model here, this object detection model can contain each and everything already there, and when the test data is arrived here, they can detect each and everything from the object detection code. So this is very easy with the Python code, that you can only give the Python model or pre-trained model to them, and then you can find out all the object or the class area from this images or containing this different type of objects with the images. Now the basic feature of object detection is the feature, like if we can generate the exact feature of the images, we can quickly identify the objects. Like here in the given image, we can see the gray level images and histogram equalization we have done. Then we have done the masking to find out the exact features from the face. Now, the radiant and wavelet function, these all functions are going to do the normalization like Haar wavelet transform, the histogram equalization. We can find this in the X to Y filtering and the normalization functions which can find the exact feature as output. We can see the 17 by 1701 grayscale images and 174001 grayscale images that is formed by Haar wavelet transform. Now we can see the positive training data set. What is positive training data set? Where we can give only the positive objects, like if we are going to recognize the phases. So the positive training data set is all the phases. Suppose 2900 phases plus 2900 mirrored phases are there. It means if we are going to take the high resolution, low resolution, or the images can be converted in blur or high intensity, that is not going to change or any effect of that feature, because whenever we are extracting our features, the eyes are as similar as the blurred image or intense image. So we are going to do this as a positive training data, where synthetic or illumination, identity, rotation, 3D morphing, these all type of functioning cannot be illiterate or that cannot be effect to extracting the similar type of features. So we extract the data from these type of rotation, morphing, illumination, these all types of function we have taken as a positive training data set. Now negative training. What is the negative training? The phase in the examined window that is not proper or appropriate, where we cannot consider the eyes, the nose, the cheeks are perfectly defined here. So these are containing as a negative data set. Again, with this negative training data set, we have to apply the bootstrapping to obtain the exact positive data, or we can say to determine the false positive or large set that is not phase images. So we have to consider it as a noisy images, where we are not considering any phase or phase features there. So these are the negative training data. Rotation. The function rotation can detect the phases also. If we are taking the photographs from the front, if we can take the photograph from the side, this is called the rotating or rotation of the images. So the training data can provide each and every type of rotation of image that can be detect you exactly. If we are considering image from the front, we are considering the image from the side, the object detection should be very clear that the person is same or the person is specifically giving the same facial recognition. So these are the going rotation that is applying in 2D rotation images and rotation invariant functions. So these features are containing the similar type of eye, nose, lips, every features are going to make a similar probation of the different type of or different angle of the faces. So this is very important object detection of features of face recognition. Now learning components one way to the prior form, where we can see there the start with small initial region, when we can see that if we are wanted to region grow or region split or region merging, where we can see the seed point is starting point, and with the starting point we can again grow with the full phase, expand in 1 or 4 directions. Like if we are going to take eyes as a seed, you can see that we can move in the 4 direction, up, down, left and right. Extract new components from the images. You can see that the upper portion is forehead, the left portion is ear, the right portion is nose, the lower portion is cheek. So these type of functions we can find out with the expanded features. Extract new components from the features, we can extract the new components. Now we are going to train the SVM classifier with this extracted features. Now we can see in the next image the eyebrows, the eyes, the nose, the cheeks, the lips. These are considering as the different features, and we have find these different features from the starting and expanded it to 4 directions. Now choose the best expansion according to error bound of SVM. What can be errors can be applied here using model of pairwise portion. Here we can see the model that is extended into a similar portions, like it expanded in the eyes, nose, lips, cheeks portion, and it extracted the features from the facial recognition. Now here we can see that application of eyes. Now the images can show the square roots. We can see the squares are showing your eyes as a training data, where each and everybody's has eyes detected as an object. The task of identification is a given image of an object of a particular class. Like example, particular class is face. Identify which exemplar it is. If we are going to take these images as identification, you can see that each faces are in a different angle. You can see front face, front face, again side face. So the similar persons have different portion or different side functions are there, and we can recognize or identified with this rotation function. So when we applied the rotation function on these images, you can easily identify that the first and second image is of same person, the third and fourth images of the same person, fifth and sixth for the same person, and 7 and 8 is for same person. Problems in face identification. Now the rotation and illuminations are the limitation of face identification. Limited information in a single face image. If we cannot provide the exact features, exact rotation, exact brightness, exact illumination to the faces, we are going to analyze poor for the face recognition. If we are not considering the features are exact, so we are going to fail to object detection of any faces. Now we are going to analyze the system architecture, where again we are training data sets we have given with the rotation function, illumination function, and the feature are extracted. Again the features are you can take the features as eyes, nose, mouth, forehead, hairs. The classifier should be support vector machine, gray, gradient wavelet. These all are classifier that is going to classify your test data according to your training output. And finally you can identify the result that the face is of similar person or the face is recognized as the object. SVM, that is support vector machine classifier for 3D object recognition. We can consider image as vector, compute pairwise OSH using the linear support vector machine. Support vector are representative wise view of the considered object relative to the other. Tournament like classification, because it is a classification algorithm, so it is comparing all the classes or the groups from the test data and training data set. Comparison classes are grouped in pair. Not selected classes are discarded. Means not selected classes is if we are going to select a class of face, so apart from faces all the classes or all the objects are non-selected class until only one class is left. Complexity linear in the number of classes, no pose estimation. So here we can see that the various application or vision application of the object detection and recognition function, that is reliable simple classifier. Use it whenever you need a classifier. When we are going to use SVM, we have to specify that we are going to use to exact class classifier, commonly used for a face finding, pedestrian finding many pedestrians look like lollipops, hands, sides, torus, wider than legs. Most of the time classify image regions searching over scales. But what are the features? Compute wavelet coefficient for the window average over if the average is different from 0, probably strongly associated with the pedestrian. Here in the feature or here in the figure we can see the blur features are there. It is a framework object detections and we are going to analyze the exact object from this blurred image, and these all images are detected by the wavelet Harlet transform, and finally with the SVM classifier we can find this final object from the image, input image. Now we can see this again images can be a pre-trained model and the squares are detecting the objects from the given input images. If we are going to train your model with pre-trained exact features or exact objects, your classifier can be object detection classifier should be give you exact output from your given input images. Here is the dynamic detection. This is very powerful sources of the object detection. When your object is moving, like your car is moving and you have to find this dynamic detection mode. So this runtime data is required to capture the images in the form of video. Like if we are going to use a car is driving to left to right and we have to snap the different type of access or car in the different instances, and we have to find this object from the pre-trained or pre-trained model, pre-trained images of car, then we could find this dynamic detection models. Static detection, that is we are seeing that the static is home, the static is tree, that is not moving further. So this is the static detection. The square boxes are going to use or going to show you the static things that is not moving, and the further image we can see that the moving images like car and the bikes, that are the static, that is the dynamic images that is moving further. Matching by the relation like idea, find bits, then say object is present in the bits are okay. Now advantages are object with complex configuration spaces, make good templates, internal degree of freedom, aspects changes, possibly shading and variation in texture. If we are going to strong these points, we can find the best object detection code for our method. Define a set of local feature template, could find these with filters etc. Corner detection filters, think of objects as pattern, each template votes for all patterns that contains it, pattern with the most vote wins. From this we can exact find the object detection and recognition from this given input, that is training input data set. All the type of dinosaur we can train for the given input images, and we have find this text image where we can find the dinosaur is there, and find the example with this training data we can find the dinosaur is present, that is object detection is there, yeah, that is present. Similar type of dinosaur is present, that is the majorly object recognition, yeah, we can recognize the dinosaur is same as given as test data. Yeah, now I am concluding this object detection and recognition topic, where we can see if we are going to take exact features, exact topics, exact object as a training pre-trained model, you can find your exact output as a object detection and you can recognize the object from this data. So this is the major input output of the images, like using classifiers, using wavelets, we have to find the exact output of from the given input. Thank you.